Hello class 10. In the last video we discussed about natural vibrations in detail and we also discussed about damped vibration. In this video today we are going to give a look at forced vibration and we are also going to look at resonance. We also are going to discuss characteristics of sound in this very video itself. So, what is forced vibration? When a body vibrates under the influence of an external periodic force, then that kind of vibration of the body is what is called forced vibration. Okay, what I have is a handmade pendulum over here to make you understand it better. So this is the pendulum. Now if I make the pendulum swing or oscillate because of the force, external force that I am applying at regular interval with my right hand, okay, then this is an example of forced vibration because I am making the pendulum vibrate or swing because of an external periodic force that I am applying right now. So this is an example of forced vibration. So to say, when you are in a swing, say for example, and a father is pushing you from behind, that is an example of forced vibration. Or not just that, when we pluck the strings of a guitar or when we use the bow to play the violin, what we are doing is we are applying an external periodic force on the strings. So the strings of the instrument, they will be executing forced vibration. Another example could be we go on banging the desk of the class. Okay, so what is the desk doing? The desk is executing forced vibration. Alright, and also when we play the flute, say for example, when we are playing the flute, we are blowing air into the flute and the air inside the flute vibrates. What is the air inside the flute doing? The air inside the flute is executing forced vibration. To put it in simple words, when we make a body, so to say, dance to our tune, okay, so the motion that the body executes is what is called forced vibration, remember.
Do not forget, in forced vibration, the body vibrates with the frequency of the external periodic force.
Let's now talk about resonance. Let me tell you at the very beginning that resonance is a special kind of forced vibration. So to say resonance is forced vibration itself, in which case therefore there has to be an external periodic force acting on the body. Alright? Now what is special about resonance is that in case of this kind of forced vibration, so to say in case of resonance, what should happen is the natural frequency of the body should be equal to the frequency of the external periodic force. Now do remember, any body will have its natural frequency. Any kind of a body, be it a solid, be it a liquid, or simply it be air, okay? Anything will have its natural frequency with which if it is allowed to vibrate, the body is going to vibrate with its natural frequency then, or so to say it is going to execute natural vibration. And the natural frequency of any body depends on the shape and size of the body. So to say a building, a tall building, however tall a building it be or however short a building it be, it will have its natural frequency. Okay? A person, I will have, depending on my shape and size, I will have my natural frequency. I have water inside a bottle, depending on how much the level of water is. Okay, the bottle and the water will have its natural frequency. A flute will have its natural frequency, depending on its length, of course. Okay, so do remember, anything that you see, any object that you see, it could be a piece of food, any object you see will have its natural frequency, remember. Now when the natural frequency of the body matches with the frequency of the external periodic force, that is when resonance occurs, what happens is the body is going to vibrate with a very large amplitude. Okay, so that is what happens in case of resonance. The body starts vibrating. The body starts vibrating with a large amplitude. Vibrating with a large amplitude. So this is what happens in case of resonance. A large amplitude of vibration of the body is produced because the natural frequency of the body and the frequency of the external periodic force, they match exactly. Let me show you a case of resonance using our handmade pendulum. So this is the pendulum and this is like its natural frequency. The natural frequency of the pendulum depends on its length and of course the size of the bob. Okay, so here is the natural frequency of the pendulum and I apply an external periodic force. So this is a case of resonance where the frequency of the pendulum matches with the frequency of the external periodic force, which I am applying with my right hand, of course. The same thing happens when you're playing in a swing. When someone is pushing you, when the frequency of the swing, that is you seated on the swing and the swing together, matches with the frequency with which a person is pushing from behind, then you are going to get a nice full swing. Okay, that is the case of resonance. Whereas see, so this is swinging, this pendulum is swinging. Okay, if I apply a periodic force like this, okay, so see what happens, see. Okay, so the lock, that is our pendulum, is not producing a nice full swing because in this case the natural frequency of the pendulum is not matching with the frequency of the external periodic force. Alright, so this is forced vibration, mind you. This is forced vibration. The pendulum is vibrating, undergoing forced vibration, but it is not producing a nice full swing. Okay, it is not producing a large amplitude. Why? Because the frequency of the external periodic force is not matching the natural frequency of the pendulum. It is undergoing forced vibration, but this is not a case of resonance. When it's a case of resonance, okay, what happens is the pendulum is going to produce nice full swing like this. Okay, so do remember, resonance therefore is a special case of forced vibration, in which case the natural frequency of the body exactly matches the frequency of the external periodic force and thereby a large amplitude of vibration of the body is produced. Okay, so this is what happens in resonance. Now there are so many different cases of resonance. Now you might have seen in some videos or maybe in some ad, okay, there is an opera singer and you have a glass, an empty glass. Okay, and the opera singer goes, sings at a very high pitch. The opera singer sings. Alright, when the opera singer is producing a certain frequency, high pitched frequency, that kind of a frequency, of course higher than that, okay, what happens is the glass breaks. Why? Because the frequency that the opera singer is producing matches with the frequency of the glass, and thereby the glass starts vibrating with a large amplitude and thereby it breaks. You might, you can check that kind of a video in YouTube also. In YouTube, search for resonance of glass, okay, and you will see that a sound is produced, high-pitched sound is produced, a very shrill sound is produced, and the glass, you will see the glass vibrating. There are videos on YouTube, okay, and you will see the vibrating glass eventually breaks. Why? Because like I already mentioned, the vibration, the natural frequency of the glass matches with the frequency of the sound that is produced, and that of course is a case of resonance. Also, when army men, they are marching. So when the army men are marching, they march with a certain frequency. Alright, they are at a certain timing. So they have a certain frequency of marching, so to say. So if you have a suspension bridge, so here is the suspension bridge, okay, and the army men are marching coming from here. They are asked not to march in the suspension bridge. Why? Because the suspension bridge will have its natural frequency, mind you. Okay, so when the army men, say for example, they march, on this suspension bridge itself, the bridge is going to undergo forced vibration. It is going to vibrate. The suspension bridge is going to vibrate. Now, if it so happens that the natural frequency of the suspension bridge matches with the frequency with which the army men are marching, what happens is this suspension bridge is going to, it will undergo resonance. So therefore, it will vibrate with a larger amplitude, and there is also a chance of the bridge itself collapsing because of resonance. Therefore, remember, this is what happens in resonance. If the natural frequency of the body matches with the frequency of the external periodic force, the body is going to undergo very large vibrations or vibrations of large amplitude. To give you another example of resonance, say we have a string which is fixed at these two ends, of course, and from this string we have four pendulums suspending, simple pendulums. And as you can see, we have pendulums of different lengths, but A and D, they are of the same length. And of course the bobs for each of the pendulums say they are the same. Okay? Now, since A and D, they are or they have the same length, and of course the bob, the mass that is hanging is the same. So therefore A and D will have the same natural frequency. Whereas the natural frequencies of B and C, of course, are different from that of A and D, simply because they have different lengths. Now what we do is, we make pendulum A oscillate. Only pendulum A, mind you. So this is like a pendulum A, and it is oscillating. I made it oscillate like this. Okay, and you leave it like this. Now after some time, what we will see is, since all of these pendulums are connected through this string, okay, so B and C will also start vibrating, will also start oscillating, but very small and only like this. B and C, both B and C. But what happens with pendulum D is, you will see that pendulum D starts oscillating. It starts oscillating very slowly with very small amplitude, so to say, initially. Okay, but A and D will start swinging or oscillating in phase, so to say. If A comes this side, D will also come this side, like this. They will start oscillating this way together in the same phase, so to say. Alright, and like I said, initially D starts swinging with a small oscillation, small amplitude, but gradually the amplitude of D starts increasing, and at a certain time the amplitude of A and D will be the same, like this. Together they will be swinging like this. And also you will see that then after, A starts swinging very slowly with less amplitude. Okay, whereas D will swing with full amplitude, full flow, so to say. Then after, again you will see that A starts gaining in energy, so to say, and A will start swinging. Okay, D will start losing its energy. Okay, so they start swinging together like this with the same amplitude. Okay, then the amplitude of D starts decreasing and A will swing with full amplitude, and the transfer of energy between A and D goes on. Okay, so there is therefore sharing of energy between A and D, and this happens because of resonance, because they have the same natural frequency, whereas B and C, they do not oscillate with nice full flow. They only start oscillating like this, very slow oscillations. So B and C, so to say, they are undergoing forced vibration. But A and D, they are undergoing resonance. So mind you, class 10, if you're asked the differences between forced vibration and resonance, you can give these different differences, so to say. The frequency of the external periodic force in case of forced vibration does not match with the natural frequency of the body, whereas in resonance they match. the amplitude of vibration is very small in case of forced vibration, whereas in case of resonance, the amplitude of vibration is large, nice full flow. Alright? In case of forced vibration, the body starts vibrating with the frequency of the external periodic force, mind you. Okay? Whereas in case of resonance, the body vibrates with its own natural frequency. So you can give any of these differences. You can also refer the book. There are some other differences given in the book. You can write that too.